Hey everyone, welcome back to class. In this lecture, we're going to be focusing on z-scores. This is going to be our first intro into inferential statistics and how we can sort of understand whether or not there are meaningful differences between patterns in our data and being able to show, in this particular case, whether or not a particular individual value is like meaningfully different from our average value or how far away it is from our average value. So the z-score is then going to be able to be used later as the foundation for other statistical testing. It's a test statistic, right? But in this intro, we're just going to be telling you how to calculate it in R. So we're going to start by loading the library that we need. So today we're only going to be using tidyverse. So you're going to load tidyverse. Now you should have probably already loaded it, but if for some reason it says that tidyverse doesn't exist in your environment, it's because you need to install it. So you'll use the install packages function for that. We're then going to be using our student data, which we've already done. So now I have my file path already set, so I can drop that in again and use the code to put it in an object called student data one. But again, you can also re-import it using the import data set. Remember, .sav is for SPSS, so you'll choose from SPSS, go to your browser and open it up properly. You also see that the code will come down here, and so you can even use that as the basis for building future code if you want to directly find the path. So give you a second to pause right here. Okay, so once you've gotten your data set up, we're using the student data set, and you've loaded the tidyverse library. We're going to be looking at finding the z-score, right? So the z-score is a measure that shows how much away above or below the mean of a specific value is, right? So how different that specific observation is from our average. Is it really far away from our average? Is it really close? Is it an outlier, or is it a good representation of our central tendency? So this is a z-score is a way that we can kind of start to look at that. It can be positive or negative, right? If it's positive, it means it's above the mean. If it's negative, it's below the mean. I need the mean and the standard deviation to start. So I need the mean of the midterm. So we're going to be using the midterm variable, right? This is one of our interval ratio variables, and we're going to be finding the average. So we're going to use the mean function, and in that first argument, we're going to be selecting out of the student data set the midterm variable, right? So student data set $midterm, and that'll give us our mean. So when we run that command return, remember I can just put my cursor, you see the little red blinking line. That means that I'm on the right line. I can just, if I'm on the right line, click command return and it'll run it, right? And command, it varies based on what sort of operating system you're using, but each operating system has a version of the command button. So command return on midterm, I find that the average midterm score for that data set is 58. That's not so great. Most people failed. I hope that that doesn't ever happen in real life, but in this fake data set, it is 58. Now, we're going to find the standard deviation, right? How far away, the square root of our variance, how far away. On average, these points are falling, right? It's 14. So there's a lot of variation, and there's a lot of people that are pretty far away from that average. So you add 14 on, and they're doing pretty well. They didn't fail, right? And 14 below, they really failed. So there's a lot of standard deviation. So maybe we want to find out a little bit more nuance as to which specific points are the ones that are really far away and which are close. We'll want to use the z-score then to see how far that particular observation is away from the mean, right? The standard deviation is how far on average all the points are away from the mean, whereas the z-score is for that specific observation. So we're going to pick the first participant. So if we look at the first participant in the student data set, their midterm score was a 54. They did not do so great. And so we want to calculate the z-score for them. The calculation will take that student's midterm grade, 54, subtract the mean, which we found out here was 58 point something something, with 58.41, and then divide the difference by the standard deviation, which we found out to be 14.35. So we can use R like a really nice fancy calculator, and we can do in parentheses 54 minus 58.41 divided by 14.35. This parentheses is very important because it's order of operation stuff. You're telling R what you want it to do first. And you'll find, this is a little typo, that this the z-score for this set is negative, or for this particular observation is negative 0.307. Why is this the case? It's because our observation, this 54, is not all that far off from the mean. So it's actually a pretty good representation of our average. But we want to know how the other students operate as well. So this was just the z-score for the first student, right? At 54. What if we want to find out the z-score for all these other observations? So there's a way that we can speed this up. So I'll give you a second to pause here and get through this stuff. So make sure you write the mean, the standard deviation function, and then go ahead and take the difference of the first observation and the mean, and then divide it by the standard deviation. So pause here. Okay, so once you've got that going, we're going to then go ahead and make this a lot faster. So remember our pipe functions, which just essentially port in the data set we want. Usually that's how we're using it, porting in the data set we want into a function. So we're going to select out of the student data the midterm variables, and we're going to put that in an object we called z-score within the mutate function. So this mutate function allows us to add new variables to our data set. Mutate right here is in the world of the tidyverse, and it allows us to make and add new things to our data set. So we're going to use that mutate function to create a new column called z-score, and that column called z-score is going to take these arguments. So it's going to find the difference between the midterm variable, each midterm variable, and the average of midterm, and then we're going to divide it by the standard deviation of midterm. Right? So this mutate function broadly is adding a column. The z-score is the new object we made, and we're giving that z-score object these components, right? Which is the z-score formula, and then we plug and chug with the variable that we want, which is midterm. It's got to be an interval ratio in this case. So we could do this with, I think hours is also interval ratio in this set. So you could do something like hours or maybe even absences. But yeah, so you have to have an interval ratio in this case. But when you run this, all right, so it's going to give us the whole set. You can go to the very last column. You got to go to the very last column, excuse me, over here, and you get the z-scores. So I apologize, I'm not on part one, but you can see when you're on the first page of this, and you're on the far right-hand side, so you get all the way to the last column, you see that the z-score actually matches, right? So we did this just a lot faster and a little bit more efficiently. So again, the z-score is a measure of how far a given observation is away from the mean, right? It gives us a little bit of additional nuance beyond the standard deviation because it gives us how that specific value falls relative to the average, in addition to the fact that we'll use z-scores and test statistics as the foundation for a lot of our statistical tests moving forward. If you have any questions about z-scores, it's going to become really important. So please talk to me about this sooner than later. And as always, if there are any issues with R, you can shoot me a message on Discord.